So machine learning, it's all about a puzzle where you know all the models, and depending on a real life problem, you will get to know which piece of a puzzle to put and where to put it. We will use a programming, we can use any programming language, but Python is one of the best programming language to use it. So in this program, in this sheet, we will be using a Colab sheet. Why we are using Google Colab is machine learning requires a lot of RAM, and RAM is really helpful for high processing. A lot of people does not have more than 4 GBs or 8 GBs or RAM. So here we will be using, so Google gives it for free for 12 GBs of RAM and some GPUs which is required for deep learning libraries. So here, as you can see, we are just importing some libraries which will be useful for programming this code and rendering it. So if you are saying, I have just added a data set called student score. It has 25 rows and 2 columns.
So just to, if you can go on the top. So people who are new to programming and new to Python, if you see from the top, what we are doing here is that there are certain libraries available. First, we need to import them so that they become available in my Colab worksheet. So pandas is for handling data. So we just import pandas. Without going in deeper into what pandas is, it is sufficient to know that if I want to manipulate data, I need to import pandas. That's it. So I import pandas. Similarly, for further manipulation and computations, there is another set of libraries called NumPy. These are the things which you either need to memorize a few things, or you can just keep a separate note for yourself. So we import pandas for data manipulation. We import NumPy for certain advanced computation. And then we import matplotlib. This is the set of libraries which help us plot graphs. Okay. So I have imported certain libraries for handling data, certain libraries called NumPy for doing advanced computation, and I am importing a library which will help me plot graphs. Okay, that is what I have done. Then if you come to the second block, which is mounting G drive, this one is,
this link, so
I have some data on my Google Drive, which I want to use, and therefore I need to define path. So I'm saying from google.colab import drive. It means that whatever is my personal Google Drive, I am making that drive accessible. Then that drive has to be mounted. So that command is given as drive.mount. And after that, now we'll create a data set locally by reading it from our drive. So if you see, it says data set is equal to pd.read.csv. Now, if you see PD, this PD was our pandas. So when we imported the panda libraries, we gave them a name, and that name is PD. So that name could be ABC, that name could be XYZ, but just for the sake of convention, mostly when we import pandas, we give them the variable name as PD, but that could be ABC, that could be XYZ, that could be anything. So now here we are saying that data set is equal to pd.read.csv. It means that now I am defining a specific data set by using the library pandas, which I had imported earlier, and I am using a read CSV command. So read CSV, if you see, that's so intuitive that I am going to read a CSV file. So this is the method from the pandas library, which will, so I'm going to read a CSV file, and then within the bracket, I give the name of this CSV file. Okay. So that is what we are doing in the third block, which is reading data set using pandas library. So now data set becomes a local data for me to manipulate inside my Colab library. So we can proceed.
Yeah. So now let us see how many rows and how many columns it has. We will be using our variable called dataset, and we use an object shape. So as you can see here, it says 25 comma 2. How to interpret that is, it has 25 rows and 2 columns.
So basically, if you see, the pandas is using a very simple language. It says, rather than saying in English language that show me the shape of the data set, and when we say shape, it is how many columns, how many rows, and all that. In English, we would say that show me the shape of this data set. In Python, we are saying just data set dot shape, and then it shows you the shape of the data set. So it shows you that this data set that I have imported, it has 25 rows and 2 columns.
Now, if you want to see only the top 5 records, we will just type dataset.head. It gives us the top 5 records. If you only want to see the first record or the second record, we will use dataset.head and give a parameter 1 or 2. So if we want to do some statistical analysis of the data set, suppose what is the count, mean, standard deviation, max, mean, something like this. So you don't have to code it. Uh, Pandas also have a describe function which intuitively gives you all the relevant and required statistical needs. In this code, as you can see, we have written dataset.describe. It gives us the count, total number of the rows, what is the mean, what is the standard deviation, which is the most minimum value, and what is the most maximum value.
So here also, if you see the simplicity of the language, that when I meet a person, if I want to know more about that, say, we would say that describe that person. Then he will say that his height was so much, he was fair skin, he was slim or he was fat. So you will give some description of that person. That is what we call describe. Now, if you have to find the description of a data set, we simply say dataset.describe. And then it shows the different parameters based on which we can understand that data set. It says that, okay, this data set has 25 records. The mean value of the different data elements that we have, that is how many number of hours the student has put in and what was his score. So it shows that what was the mean, what is the standard deviation, what is the minimum value, what is the maximum value, and the different percentile scores, 25 percentile, 50 percentile, 75 percentile. So these things I can just see very quickly by saying, so rather than saying in English, describe my data set, we just say data set.describe. Now, with the past 2-3 commands, we would have started seeing a pattern on how this language works. For example, when we speak the English language, the composition of the sentence is somewhat different compared to most of the Indian languages. So for example, the positioning of the word and the noun is different in English compared to Hindi or Telugu or Kannada. So similarly, in English, if we say describe the data set, in Pandas, we'll say data set.describe. So that is the pattern you will see throughout, that whatever we want to do, we put that after on whatever we want to do. So we want to see the description of data set. So we'll write data set first and the verb will come later. So data set.describe. It is nothing but saying in English that describe the data set for me. Okay, let's move on.
Now let us just visualize data set. I will show you how easy it is to visualize data set. Now, if I want to just plot data set, I will write dataset.plot. In the parameters, I have given what will be the x-axis and what will be the y-axis. I have given x-axis as hours and y-axis as score. Now we are using the matplotlib library here, where we say plt.title, which will be the title of our graph. And what will be the label and what will X label and Y label? It's our studies and Y label is percentage score. Now, if we just type plot dot show, it will populate the graph. As you can see here, the graphs have been populated with x-axis as our studies and y-axis as percentage score.
If you can run that once again, plot here.
Run again. In dataset.plotlib, if you just want to plot a dataset, we will just write dataset.plot and mark the parameters on what all plot you want. Suppose we want at x-axis, we want hours, and at y-axis, we want scores. So I have just mentioned x equal to hours and y equal to score. And if we just write plt.show, it will plot the graph. So aesthetically, if you want to add what is the title of the graph, we will write plt.title, which is hours versus percentage. If you want to give what will come after the x label, what is the name of the x-axis, we will write plot.x label, the hour studies, and the y label as percentage score.
Maybe if you can just change one of them and
run the whole.
ऊपर से रन करते हुए हो जाएगा तुरंत. So as you can see here that there are two steps here. One is that we type the command, and the second one is that we can run the command. So earlier you saw what was typed. So we have gone back to block number 1. And then I have asked Shubham to run that command 1. To run that command, you have to just click on the play button, and that command is run. So he is running those commands. As you can see that as the command is being run, the output would be generated once again. So now he is publishing the data set head. Earlier, so he put the parameter of head 1. That means I want to see the top 1 record. The default value is 5 records. So he put the parameter as 1, and you see that we saw only 1 record. Then I am asking him to again describe the data set, which has been done. Now, earlier you are seeing here that certain graph was plotted. I'm asking him to change certain parameters and then run the graph again. So as he is clicking on the play button, the graph is being run again. And as you can see that the title of the graph has been slightly changed. The X label, the Y label has been slightly changed. So if you do this kind of experiments, you will see that what command is actually changing what. Okay. So until now, what we have done is that we have read a database which gave me the data of the number of hours put in by a student and the corresponding scores. So we first imported the libraries, which will enable me to do all the further computations. Then I read that specific database from my drive. Having read the database, then I wanted to get a feel of how this data look like. And that's where I gave 2 commands. One was the head, which showed me that what is the shape, how does the records look like. So the top 5 records I saw. Before that, I wanted to see what the shape of the data, that is how big is the data, how many columns, how many rows, and so on. So that part was taken by dataset.shape. Then after that, I saw the actual records. How do they look like? So I went for the top 1 record. If you don't give the parameter 1, it by default shows top 5 records. Then I sought some more information about the data set, that how many records are there, what is the minimum, what is the maximum, the different percentiles, standard deviation, and so on. Then I wanted to get a visual feel of the data, that how does the data really look on a graph. And then I had imported earlier the libraries matplotlib. Using that, now I have been able to draw a graph. So as you can see that until now, the number of commands we have given is actually very minimal. And also, very quickly, you will start finding out a pattern as to how the commands need to be given to Python language. So having drawn that, now we will move to the next one. Okay. So now I have seen the plot of this graph, and the problem that we are trying to solve is that if I have the information about how many number of hours the student has put in and what was his actual score. So now I see it visually. The problem I'm trying to solve that if I come across a new data element, that is, if I come across a new student who has put in certain number of hours, will I be able to predict what the likely score going to be? That is the problem we are trying to solve. So I have now a feel of the data. I have seen how the data looks like, how the data looks like when I plot it. Now we will do the actual machine learning algorithm. That is, we will run a regression using the machine learning libraries.
So machine learning consists of features and their attributes and their labels. So in this X and Y, these are the two data sets. In X is the features and Y is the label. So we teach the machine what X corresponding features are, which is equal to the labels. Suppose a person, suppose I study for 5 hours, what will my percentage score be? So 5 is a label. So 5 is a attribute or a feature, and the percentage score corresponding is a label. So here I have just divided my data set into two parts, X and Y, which is the feature and the label.
So if you see here, one is in the high school mathematics, if you recall, one is the known variable and the second is the unknown variable. So it is the X which will predict Y. So X is the variable which I will know in future, and Y is the variable that I will have to predict. So I would, if I have the number of hours known, can I predict the score? So X is the number of hours known. That is what we are calling as the feature. And Y, so the past data, when I have the input variable, which is the number of hours, and I have the output variable, which is the score. So the output variable we call as label, and the input variable we call as feature. So some of these things you will have to learn in the context of the machine learning, because the language of the machine learning will be slightly different from, even if you have done the mathematics earlier, it will be slightly different. So here the input variables we'll call it feature, and in this case, to keep it simple for the time being, we have taken only one input variable. But as I was explaining earlier, that the input variables could be many. So if I want to predict that whether this person is a suitable person for selling a car or not, the input variable could be income, how many vehicles he already has, whether he owns a scooter or not, what is whether he owns a house or not. So some of these things could be different input variables. But this is the first example that we are taking, so we'll keep it simple. There is only one input variable, that is how many number of hours he has studied, and the output variable is the score. That is what we are calling as X and Y. So here when he's saying X is equal to data set dot something, 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 we'll come to some of these things in detail later. Basically what he is saying is that X is my first column in the data set. Okay, how it is deriving the first column? If you see, it is actually saying that in the data set, leave the last column and read everything else. So since here we have only two columns, it is leaving out the last column, which is the score, and it is taking everything else. It means that everything else is being treated as the input. input column. So these are some of the commands that you will have to learn, not very difficult to do. It will say data set dot something 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 -1. It means that read everything in data set, leaving out the last column. Similarly, he is saying the y is the last column of the data set. So when you're saying here 1, the system is reading as 0 as the first column and 1 is the second column. So it is here actually saying that read the second column of the data set, and that is my output.
So in the next step, we will split into the training and testing part. So as you can see, I have imported a library called sklearn, and I have imported their functionality called train and test split. Here, we will just split x and y into x underscore train, x underscore test, y underscore train, and y underscore test. If you see the parameters, I have given 80 to 20 percentage. 80 percentage is the training set, and the 20 percentage is the test size. In the next line, we will now start our machine learning model. So here from sklearn, scikit-learn is the machine learning library in Python, built in Python. So from sklearn, we are using a linear model. So there are multiple linear models, and from that linear model, we are going to use the model called linear regression. So if I hover over it, you can see all the parameters and how to use this library. So now I am going to assign a model of a variable to this model, regressor equal to linear regression. So just as we use pandas, we use something called data set, and then we use head or describe. Now I will use regressor and ask my computer to learn it. So I use regressor dot fit x train underscore y train. Now I ask the computer, so for all my labels, all my features, these are the labels. Suppose if I learn for 3 hours, my score is 30%. If I learn for 5 hours, my score is 55%. In this command, I teach them what is the features and what are the labels are. Yeah. So as now in the last step, my computer has already learned, we will ask it to predict. So regressor.predict. X test was something I had given up. I had earlier divided my data set into 80% for training and 24% for testing. So for prediction, I will using the remaining of my text of my data set, which is the X test. So regressor.predict, and I pass the parameter called X test. It tells me what is the prediction. This prediction is done by my computer. So if I see here, actually the answer was supposed to be 20 and he has predicted as 16. The output, if you see, actual was supposed to be 27, it has predicted 33. So which gives me that it is as good as me or someone as a human who can predict things.
Okay, so now just to slightly go to recaps here. So after we have done the plot of the raw data, then actually now we are going to run the machine learning algorithm. As I had described earlier, that the problem we're trying to solve is that if I come across a new data element that this student has spent so many hours of learning, can you predict that what his score would be? So now we want the machine to do the prediction. So we will ask the machine to learn from this data which we have given to it earlier and become able to predict. So to be able to do that, to be able to train the machine, or to be able to make the machine learn from the data, there are certain steps that we need to do. So the first one, we tell the machine that which one is the input variable. That is where we decided X is equal to data set dot something, 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 where we told the machine that your input variables are every column but for the last column. So that now the machine takes as the input variable. Now Y is, and that is what we are calling in the nomenclature of machine language as the feature. Now we ask the machine that read what is the output variable, and that is given in the and that is what we store as Y, and this is the last column in the data set that we read. That was Y. Now in the process of making the machines learn, this is what we will learn later on, is that every time that we have been given a data set and we ask the machines to learn, we also need to assess that whether whatever the machine is learning, is that right or not? Because unless we make that assessment that the machine has learned the right thing, we should not be deploying that in the real life situations. And that's why even before we go to the real life situation, what we do is that whatever data we have, we divide that into two segments. One segment we call is the training segment, and one is the testing segment. So for example, here we had the 20 data elements. We are dividing that into 80% for training the machine, and the remaining 20% to test that whether my training has been good or bad. Okay, that is what is being done in line 4 or 5 here. So we just import the library. So as you can see that even though we are running a very complex process like regression, the coding that you have to do is very minimal. The coding is, what you are doing is that in first read the data set, then you are telling the program that in the data set, which columns are my input data and which column is my output data. Then you are just importing a library. So from sklearn, you are importing a model, and then the machine itself will actually split your data. You don't have to do the specific coding that these are the data elements for training and these are the ones which will be used for testing. No, you don't have to do that. You just import the library and say that import train test split. It means that this is the function which will split your data into the training data and the testing data. The next line, which is line number 5, we are again saying that this is the training data of the X, that is the input, and the testing data for input. Similarly, for the training data for output and testing data for output. And then as I give the command train test split, the system will split the data given the ratio. That ratio also can be defined. So here we have said the testing data would be 20%. So system automatically understand that the training data would be the remaining 80%. Now, having split my data set into the training data and the testing data, now I again import a library called linear regression, and then say that run the regression to fit the data on X train and Y train. That's all we have to do. So to be able to run the regression, you just say regressor.fit, and then what is the training data for input and what is the training data for output. So I have put X train and Y train. Beyond this, now the system has already done its own learning. Now we need to test that how effective this learning has been, and therefore whatever the machine has learned or whatever algorithm now it has arrived at, now we will say that okay, run this algorithm and make the prediction on the test data, because on the test data I have the actual numbers already. Now whatever formula that the machine learning algorithm gives me, I will use the input data on that formula and see that what is the output. and then I'll compare that output with the actual output. So I see that when my actual was 20, the prediction was actually 16.8. When my actual was 23, the prediction which the machine now is doing is 33. When it should have been 69, the machine is saying that 75. When it should have been actually 30, the machine is saying 26. When the actual should have been 62, the machine is now saying it is 60.49. So we get a visual approximation and said, okay, the machine looks like doing more or less correct, although it is not very accurate. And then we will go and see that how accurate is that. And for that, we have certain parameters. So now we are plotting the actual versus the prediction. The actual one is getting predicted on the red line. Sorry, the prediction we have made is on the red line, and the actual ones are actually the blue dots. So you see that the prediction which the machine has done is more or less correct. And again, for plotting this graph, I did not write too much of a code. It's actually just I copied from the above, and just this 4 line of code, it is again giving me the visual representation of what is the prediction which my machine has done and what is the actual in the real life. So my regression problem is done. Now I will just one more step is that, okay, visually it looked more or less fine to me. 20 was coming 16, 27 was coming 33 and so on. But how much is it actually accurate? And that one is in the last one. These are some of the parameters which tells me that how close it is. So for example, if it is the mean absolute error is 4.18, the mean squared error is 21. Now, what is the acceptable range? That will depend upon what kind of problem you want to solve, how much of the error you want to leave. So how to interpret this data? These are some of the things that we'll go through. So the mean squared error of 21, in this kind of situation, we can say that, okay, this is in the acceptable range. If it is not in the acceptable range, then we will see how we can refine that logic further. So these are the things that we will have to learn. Now, in the entire process, if you see, running a full regression pack, we have hardly used about maybe 12 to 15 lines of code. And that too, these are not very complex. This is, after you have practice of say a week or two, you will start understanding that what kind of syntax does the Python as a language understand. But the critical part here is that all the complex things that we did, for example, actually running the regression, actually training the machine to find out the best fit line, arriving at the formula, all this is done by the machine. What we need to learn is how to make the machine learn. So our learning is not really to go into the complex theory of regression. That is how the regression computation is being done, how the mean squared error is computed, how it is optimized. Those things are not the ones which in today's world or the kind of algorithms we have available, we don't really need to learn those computationally very taxing processes. Those will be done by the machine. Those would be done by the libraries. What we need to learn is how do we really use that? How do I really read the data? How do I split the data? How do I feed that data to the algorithm? So if you see, more or less, we are in a situation where learning the machine language has become very close to driving a car. So all the complexity is hidden inside the hood. You don't know, or you don't need to know how the engines are operating, how the fuel is going into the engine, and how the internal combustion is happening. What is the theory behind that? You don't really need to know. You enter the car, you know how to start the car, you know that there are some 4, 5, 6 levers. I have a clutch, I have a gear, I have a brake, I have a steering, I have a horn, and how these things are to be used. Similarly, in today's machine learning, you don't really need to go under the hood and find out that how the engine is actually operating. You really just need to know that how to start the engine, how do you rev up the car to by putting your feet on the accelerator, how do you slow down, how do you turn the car. That is what you need to learn here. So I hope this example has been able to show to you that maybe just in about 15, 16 lines of code, you can run a full regression engine and arrive at a prediction model of how much could be the score of a student based on how many numbers of hours he has put in. Now, if I give you, having done that, if you have the access to a data, which is about the consumer, how much is income, where he works, how many years of experience, uh, how many vehicles he has, what is his bank balance, then based on that, can I predict that whether he would be a suitable candidate for selling a car or not? Now, you would be able to solve that problem very easily in the same manner, because what is going to change is just the data. So rather than having a data on number of hours studied and the score, you will have data on different attributes of the individual, and my output would be that whether he is going to buy a car or not.